And this is part 2 on using the 555 timer as a timing circuit. So in the previous video, I kind of talked about how a 555 timer is used as a monostable vibrator. So it gives a high pulse for a short while and goes low again. So in this part 2 lecture of the 555 timer, I'm going to show you how to configure the 555 timer as an astable multivibrator. That means the output is going to be a high, low, high, low, high, low, high, low. So it's going to be like a frequency rectangular wave sort of thing going on. Okay, and this is how it will look like. Okay, this is the output, and I'm going to show you. So this is called the astable multivibrator. Okay, remember this. And I'm going to show you how to pin it up. So you'll notice that the pinning of the 555 is slightly different. There is no trigger. There is no trigger. So once you have VCC power in, boom, there it goes. It's going to give you a high, low, high, low, high, low output. Okay. And what you must also notice is that there is no, in the previous chapter, when it is configured as a monostable, pin 6 and pin 7 was shorted. Now, as a astable, pin 2 and pin 6 is going to be shorted. So pin 7 and pin 2 is going to be connected with R1, R2, and C1 in this manner. Okay, so the only difference is what's happening on the left hand side between pin 7, 6, and 2. On the right hand side, it is the same. Pin 1 is still ground, pin 8 is still VCC, reset is still VCC, control is still connected to the ground via a 10 nanofarad capacitor. Okay, and this output is connected to whatever transducer you want, buzzer, LED, motor, so on and so forth. All right. Now, here what it does is that pin 2 is going to bounce between 1/3 and pin 6 between 2/3. So it's going to bounce between 1/3 and 2/3 between pin 2 and pin 6. So every time it is going to hit pin 2/3 VCC, output is going to go low. Yeah, but every time it wants to go below 1/3, the output is going to go high. And then it hits 2/3, it's going to go low. It goes, once it go below 1/3, it goes high. So in this case, it's going to, the pin 2 and pin 6 is going to bounce between 1/3 and 2/3 VCC. And since it's bouncing between 1/3 and 2/3 VCC, the output is also going to go high, low, high, low, high, low. Okay, and the time where it is high, we are going to call it T on. The time when it is low, we are going to call it T off. And the time taken for one complete oscillation is called the period. There are formulas for these. I believe this will be given in your formula sheet, but you have to, well, it's always best to go and remember it. Yeah. So to calculate the period, okay. So this is the period. Use this formula to calculate the T on. This is the T on. Use this formula. And to calculate the T off, the time where it is low, use this formula. All right. So go and remember these three formulas. Go and remember these three formulas. The duty cycle, if you remember the earlier chapters, is the time that it is high over the total time multiplied by 100%. That's your duty cycle. I'm not going to spend too much time on this. I've already taught you what duty cycle is in the earlier chapters. Frequency is just 1 over the period. I've also taught you this before. And that's it. That's it. All you need to know is how to wire up your 555 timer as a stable multivibrator. And some of you will be going, whoa, so how do I actually use this? I mean, it goes on and on and on. I can't turn it off. So here's the thing, right? What we would usually do is use the VCC as the input from the previous subsystem. So whatever, now I can actually use LM 311. I can actually use a LM311 so that when it goes high, give me a 5 volt, assuming that's a VCC, and I'm going to input this in here so that when this goes high, it's going to trigger this fella into a multivibrator, astable multivibrator output. So this one can be connected to the buzzer so that when my non my inverting my non-inverting, sorry, is greater than my inverting, it goes high, 5 volts, hits the VCC, gives it 5 volts VCC, the buzzer will buzz. Yeah, so that's basically how it works. And then for whatever reason, whatever the situation, if the inverting goes higher than the non-inverting, it goes low. Basically, the VCC gets cut off. No VCC, it stops buzzing. It stops giving out the signal. So essentially, that's how I would connect it to give me a astable output. Okay, so I've kind of explained both monostable and astable. I hope it has made it slightly clearer to you guys. You can go and try out these examples. Go and remember how to wire up both astable and monostable configurations. Go and try out these examples. If you have any questions, you can, same thing, email me, or you can look for me in school. All right. Um, yeah, that's about it. So 555, again, is very important to know the working theory behind it, but it is also equally, and if not more important, to know how to use it in your prototypes. Okay, you must be very clear about the wiring. You must be very clear how your inputs work, how your outputs work. Yeah, so again, I hope this video has helped you gain a better and clearer understanding of what a 555 can do and how it works and how it can help us do certain things. Okay, with that, I will see you. Goodbye.